Hey everyone, Mr. Kaczynski here. We're going to graph an absolute function today. In my last video in this section we made a table of values for an absolute value function. So we'll combine that idea with some new ideas here as well. Alright, so this is the most basic of absolute value functions. It's what we would call it the parent function, y equals the absolute value of x. Its vertex is at 0, 0. And then the absolute value of, because the absolute value of 0 is 0. All right, and then the absolute value of 1 is 1. The absolute value of 4 is 4. The absolute value of -3 is 3. The absolute value of -10 is +10. So something like that would give us our absolute value function. It would look like this. Okay, and that's what all absolute value functions look like. They're V's, V-shaped, and their vertex is a very important point. Okay, so let's keep going here, and I'll introduce some other ideas. Okay, so the vertex of this is at 0, -4. Okay. The 0, if I plug a 0 in there, it'll make the absolute value quantity 0. And that's important. That's what we want. And then this -4, that's going to be our y-intercept, okay? So, and then we can plug in some different values. So let's go from there. Let's make in fact, let's use some mental math here and we'll make a table of values. So we'll have an XY table. We're going to plug in -2, -1. We already know that 0 gives us -4. And we'll also plug in +1 and +2. So -3 times -2 is -6. The absolute value of that is 6, and 6 minus 4 is 2. -3 times -1 is +3. The absolute value of 3 is 3, and 3 minus 4 is -1. Now let's plug in 1. -3 times 1 is -3. The absolute value of that is 3. And 3 minus 4 is -1. And we'll plug in 2. -3 times 2 is -6. The absolute value of that is 6. And 6 minus 4 is 2. Notice the symmetry there. 1, -1. 2, +2. -1, -1. -2, +2. That's symmetry. And that always occurs in an absolute value function on either side of the vertex, much like a quadratic function. Okay, this one changes things up a little bit now. Let's identify the vertex first, and maybe you'll start seeing a pattern here. The vertex this time is at 1, -8. Right here. Okay, why? Because when I plug 1 in there, it makes the absolute value function 0, and then the output would be the absolute value of 0 is 0, and 0 minus 8 is -8. So that's our vertex. Let's make a table of values and complete the rest of it and see what happens. So I'm going to use 1 as my middle there. And I'll plug in a couple values on either side, 0 and -1, and we'll plug in 2 and 3 as well. Okay, -1 minus 1 is -2. The absolute value of that is 2, and 2 minus 8 is -6. -1, -6. Watch what happens when we plug in 3. 3 minus 1 is 2. The absolute value of 2 is 2, and 2 minus 8 is -6. So 3, -6 as well. 0. 0 minus 1 is -1. The absolute value of that is 1, and 1 minus 8 is -7. So 0, -7. And then also 2. 2 minus 1 is 1. Absolute value of that is 1. And 1 minus 8 is negative 7. So 2, negative 7. You see the pattern there. And that's going to be our absolute value function, our graph. So notice that the vertex was at 1, negative 8. Where do you think the vertex is going to be here? Take a guess. Here it comes. The vertex of this absolute value function is going to be at negative 3, positive 2. Negative 3, positive 2. Okay, are you seeing it? The opposite of that value for the x and this value exactly for the y. Let's make a table of values. We're going to put the vertex right in the middle. And we'll pick a couple values to the left and a couple values to the right. And then we'll do some mental math. So how about negative 4? Let's put that in first. Negative 4 plus 3 is negative 1. The absolute value of that is 1. 1 times 3 is 3, and 3 plus 2 is 5. Negative 4, positive 5. Let's plug this negative 2 in. Negative 2 plus 3 is 1. The absolute value of that is 1. 1 times 3 is 3, and 3 plus 2 is 5. Notice the symmetry. So negative 2, positive 5. I'm going to even switch colors here. Put the negative 5 in. Negative 5 plus 3 is negative 2. The absolute value of that is 2. 2 times 3 is 6, and 6 plus 2 is 8. So negative 5, positive 8. And the negative 1, you know what it's going to be. Negative 1 plus 3 is 2. The absolute value of 2 is 2. 2 times 3 is 6, and 6 plus 2 is 8. So negative 1, positive 8. All right, and so our absolute value graph looks like this. Okay, so we're learning something about the function or the vertex. Do you notice the slope of each one of those lines? Isn't that got a slope of 3, and doesn't this one have a slope of negative 3? I wonder if there's something to that. All right, and let's look at this one, last one here. Let's talk about the vertex first. Do you know what the vertex is? Take an educated guess. It's coming at you now. The vertex is at 0, 2. 0, 2. Right there. We're going to make a table of values. We're going to put 0, 2 right in the middle of it. For my, I wanted to do my 0, 2 in purple. All right, and then for my other inputs, I'm going to use negative 1, negative 2, and positive 1, positive 2. So when I put negative 1 into this function, the absolute value of negative 1 is 1. 1 times negative 6 is negative 6, and negative 6 plus 2 is negative 4. So negative 1, negative 4. And then we'll plug 1 in. The absolute value of 1 is 1. 1 times negative 6 is negative 6. Negative 6 plus 2 is negative 4. And really, we have enough points right now to graph it, but I'm going to do a couple more just to illustrate this to you. Switch colors even. The absolute value of negative 2 is 2. 2 times negative 6 is negative 12, and negative 12 plus 2 is negative 10. So negative 2, negative 10. And then 2. The absolute value of 2 is 2. 2 times negative 6 is negative 6, is negative 12. Negative 12 plus 2 is negative 10 again. So 2, negative 10 right there. So notice some key things about this graph. Okay, number 1, the vertex, 0, 2. Hopefully you can see where that's coming from out of the equation. And then notice the slope of these lines. Doesn't this part on the right have a slope of negative 6, and the slope of the part on the left have a slope of positive 6? See where that's coming from? And this one's pointing down, whereas all the other ones were pointing up. I wonder if that negative sign has something to do with that. We're all going to discuss more of those stuff in the upcoming skills in IXL's Algebra 1 section double D, graphing an absolute value function today. Identify that vertex and plot a couple points on either side of the vertex. Good luck.